The universe holds more secrets than we have yet discovered. Among the countless stars and galaxies, one catalogue stands as a gateway to these enigmas, the new General Catalogue. Within its pages lie celestial objects so bizarre, they challenge everything we think we know. By the end of this journey, you will have witnessed 25 cosmic anomalies that defy simple explanation. We will see a nebula that flickers like a faulty street lamp and a galaxy tearing another apart. What is the strangest thing you believe could be waiting in the dark? Our first stop is a celestial object that refuses to stay still. Catalogued as NGC 2261, it is known as Hubble's variable nebula, a name that hints at its restless nature. This is not a static cloud of gas and dust but a shape-shifter, a nebula whose brightness and form can visibly alter over just a few weeks. Seen through a telescope, it resembles a delicate, luminous fan or a comet's tail sweeping across the blackness of space. The heart of this mystery is a young, tempestuous star named R Monocerotis, buried deep within the nebula's base. This star is variable, meaning its light output is not constant. It flickers and flares unpredictably. Think of it not as a steady bulb in a lamp, but as a flickering candle hidden behind a complex screen of gauzy fabric. The fabric is the nebula itself, vast curtains of gas and dust. Every change in the candle's flame casts new shadows and highlights, making the entire screen appear to morph and dance. That is the simple beauty and profound puzzle of Hubble's variable nebula. The star's erratic light illuminates different filaments and pockets within the dusty shroud, creating an ever-changing cosmic silhouette. Even the great astronomer Edwin Hubble, for whom the nebula is named, was captivated by its fluctuations. He studied it intently, trying to decode the rhythm of its changes, but the nebula refused to follow a predictable schedule. This behavior challenges our basic models of how light interacts with cosmic material. It shows us that illumination in space is not always a serene, constant bath, but can be a strobe-like effect, revealing structure in fleeting glimpses. The nebula acts like a lighthouse, but one with a wildly irregular beam, sweeping across the universe and forcing us to watch closely, lest we miss its next transformation. From a flickering nebula, we travel to a scene of cosmic violence on an unimaginable scale. Our second strange object, NGC 5128, is better known as Centaurus A, a name that belies its monstrous nature. This is not a serene island of stars, but a colossal elliptical galaxy caught in the act of a brutal feast. At its heart lies the aftermath of a catastrophic merger, a spiral galaxy it has torn apart and consumed. The evidence of this galactic cannibalism is written across its face in a stark, dark band of dust, a ragged lane of cosmic debris that cuts the glowing sphere of stars in two. It is a scar from a collision that happened hundreds of millions of years ago, a permanent tattoo of destruction. But Centaurus is more than just a relic of a past collision. It is an intensely active and dangerous beast. It holds the distinction of being the closest active radio galaxy to Earth, a mere 12 million light-years away. This proximity gives us a front-row seat to its furious core, where a supermassive black hole, weighing in at about 55 million times the mass of our Sun, is actively feeding. The energy released from this feast is not subtle. It powers two immense jets of plasma shooting out from the galactic core at nearly the speed of light. These are relativistic jets, streams of particles so energetic they glow fiercely in radio waves, stretching for over 1 million light-years into intergalactic space. That is farther than the distance between our Milky Way and the Andromeda Galaxy. These jets are the source of the galaxy's radio roar, a signature so powerful it was one of the first celestial radio sources ever identified. Centaurus A serves as a prime laboratory for understanding the most violent processes in the universe. Here we can study the messy physics of galactic mergers, watching how the structure of one galaxy is utterly dismantled and absorbed. We can observe how such a collision funnels vast amounts of gas and dust directly into the waiting black hole, turning a quiet giant into an active, ravenous engine. It shows us that galaxies are not static but dynamic and often violent entities, growing and evolving through catastrophic encounters. This monstrous galaxy, with its dark dust lane and brilliant jets, is a constant reminder that beauty in the cosmos is often born from destruction. From the violent chaos of a galactic collision, we find a strangely serene and symmetrical beauty in death. Our third object, NGC 3242, is known as the Ghost of Jupiter, a planetary nebula that hangs in the cosmos like a luminous celestial eye. Through a telescope, its pale, blue-green disk does indeed bear an uncanny resemblance to the giant planet in our own solar system, but this is no world. It is a funeral shroud. This breathtaking glow is the final breath of a star, a sun-like star that has reached the end of its life. In its death throes, it expelled its outer layers into space, creating a vast, expanding shell of gas. The intricate, onion-like layers you see are the result of multiple pulses of material, cast off at different times and now illuminated by the intense ultraviolet radiation from the tiny, hot core left behind. That core is a white dwarf, an Earth-sized ember of stellar carbon and oxygen, unimaginably dense and slowly fading into darkness over billions of years. But the ghost of Jupiter's beautiful symmetry masks a violent history. Its distinct bipolar shape, with what appear to be faint wings or jets extending from its central oval, tells a story of fast-moving material shot out from the poles of the dying star. Think of a spinning garden sprinkler where water jets out strongest from the ends as it rotates. In a similar, though far more colossal process, the dying star channeled its final energetic outbursts along its axis, sculpting the nebula into this elegant, hourglass-like form. This beautiful object is a direct message about our own sun's eventual fate. In roughly 5 billion years, our star too will swell into a red giant, engulfing the inner planets before casting off its own glowing shroud and leaving behind a white dwarf cinder. The Ghost of Jupiter is a preview of that distant day, a reminder that even in stellar death, there can be a structure and a haunting beauty that echoes across the light years. It shows us that endings are not merely an erasure, but a transformation, painting the void with the illuminated history of a star's final act. The serene symmetry of the Ghost of Jupiter gives way to planetary nebulae with faces. Our fourth object, NGC 2392, is famously called the Eskimo Nebula. Through a telescope, the resemblance is startling, a cosmic portrait of a face surrounded by a fur-lined parka hood. This hood is a vast, faint halo of gas ejected by the star thousands of years earlier. The face itself, a bright inner ring of glowing material, is sculpted by a far more recent and violent event. Here, a fast wind of particles from the exposed hot core of the star is slamming into the older, slower-moving shell of gas. This collision heats and illuminates the inner edge, creating that sharp, bright ring we see as a face. But the portrait is not flat. Streams of material are shooting out from the star's poles, creating the illusion of a three-dimensional hood with tufts and streamers. This structure reveals a star that did not die quietly, but in a directed, powerful outburst that shaped its remains into a form we can eerily recognize. If the Eskimo presents a face, our fifth object offers a hypnotic, layered gaze. NGC 6543, the Cat's Eye Nebula, may be the most structurally complex planetary nebula ever discovered. Hubble Space Telescope images reveal not a simple shell, but a dizzying series of concentric rings like a cosmic onion, surrounded by vast, faint halos and punctuated by violent jets of gas. Each perfect ring is a fossilized record of a separate pulse, a time when the dying star convulsed and blew off another shell of its atmosphere. These occurred roughly every 1,500 years, a slow, rhythmic death rattle. Yet the intricate knots and jets at its very center defy this orderly explanation. Their precise, symmetrical shapes suggest something else is at work, perhaps an unseen companion star orbiting the primary, its gravity sculpting the outflows into those sharp patterns. Alternatively, powerful magnetic fields, like invisible hands, could be channeling the star's final breaths into such elaborate forms. The cat's eye does not simply show us a star's death, it shows us a star dying in fits and starts, with its final agony shaped by hidden forces we are still striving to understand. These intricate portraits of stellar death are not the only ways a star can say goodbye. Some final breaths create illusions that play tricks on the human eye. Our sixth object, NGC 6826, is famously called the blinking planetary nebula. Through a telescope, it presents a serene, greenish-blue disk. But look directly at it, and its faint central star dominates your vision, causing the surrounding nebula to seem to vanish. Now, shift your gaze slightly to the side, using your peripheral vision, and the nebula snaps back into view, bright and clear. This is not the nebula itself changing, but a quirk of human biology. The center of our retina is packed with cone cells excellent for color and detail in bright light, but less sensitive to faint, diffuse glow. The star's pinpoint light overwhelms it. Our peripheral vision, however, uses more rod cells which are superb at detecting faint, extended objects in low light. By looking away, you engage these rods, and the nebula's soft light suddenly registers. It is a perfect demonstration of how our own perception shapes what we see in the cosmos, a celestial magic trick played on the retina. From an optical illusion, we move to a nebula that mimics a planet in our own solar system. Our seventh object, NGC 7009, is known as the Saturn Nebula. When viewed through larger telescopes, its resemblance to the ringed giant is uncanny. At its heart is a bright, elongated central body, but the true spectacle are the Antennae. These are jet-like extensions, luminous blobs or handles of gas that project from either side of the central region, looking exactly like Saturn's rings seen edge-on. These are not solid rings, but powerful outflows, material ejected at high speed from the poles of the dying star. They are the fingerprints of a dynamic and directional death, suggesting the influence of a binary companion or intense magnetic fields that funneled the star's final gasp into these focused beams. The Saturn Nebula shows us that even in the chaos of stellar exploration, physics can create forms of startling symmetry and familiar beauty. If the Saturn Nebula shows direction, our eighth object presents near-perfect spherical harmony. NGC 7662, the blue snowball, lives up to its name with an intense aquamarine hue and a remarkably round, crisp appearance. This vivid blue color comes from doubly ionized oxygen atoms within the hot gas, glowing under the fierce ultraviolet light of the central white dwarf. Its almost perfect spherical symmetry is a clue that this star may have died a relatively quiet, symmetrical death, without the strong bipolar outflows that shape nebulae like the cat's eye or the Saturn. Yet, even here, high-resolution images reveal subtle complexities, faint rings and slight elongations within the main shell. The blue snowball represents a different pathway in stellar evolution, one where the final expulsion of a star's atmosphere was more uniform, like a gently expanding bubble. Together, these three nebulae, the blinking planetary, the Saturn, and the blue snowball, illustrate a profound truth. They are all the graves of sun-like stars, but their monuments are not identical. The final form is a cosmic sculpture shaped by the star's rotation, magnetic fields, the presence of companions, and the precise rhythm of its death throes. Their beauty is a direct record of the physics of their demise. Sometimes the most profound mysteries are not what we see glowing, but what we see missing. Object number 9, NGC 1999, the Keyhole Nebula, presents exactly that puzzle. Nestled within the vast stellar nursery of the Orion Molecular Cloud Complex, this reflection nebula should be a cloud of dust simply reflecting the light of nearby stars, creating a soft, ethereal glow. And indeed, much of it is, but at its heart lies something startling, a sharply defined triangular patch of absolute blackness. For decades, astronomers believed this dark wedge was a Bok globule, an extremely dense, cold cloud of gas and dust so thick it blocks all background light, appearing as a silhouette against the brighter nebula. These globules are often the birthplaces of future stars, so the explanation made perfect sense. It was a cosmic cocoon waiting to hatch. Then the Herschel Space Observatory turned its far infrared eyes toward it. Instruments designed to see the faint heat glow from the coldest dust should have detected a signature from that dense, dark cloud. They saw nothing. The triangle was not a dense cloud at all. It was a genuine hole, an empty void in the fabric of the nebula. The implications were immediate and profound. This was not an object, but the absence of one. The leading theory points to the energetic young star V380 Orionis, which illuminates the rest of the nebula. In its violent infancy, this star likely ejected powerful jets of material from its poles. Think of it not as a gentle breeze, but as a cosmic blowtorch. These jets, streaming out at tremendous speeds, may have simply blasted away all the dust and gas in their path, carving out this clear, geometric tunnel in space. The Keyhole Nebula, therefore, is not just a pretty cloud. It is a snapshot of stellar feedback in its most direct form, a visible scar from the birth pangs of a star. It challenges the simpler model where nebulae are passive clouds slowly collapsing under gravity. Instead, it shows us that star formation is a dynamic, often disruptive process, where newborn stars actively reshape their own nurseries, clearing out cavities and influencing the birth of siblings. That dark triangle is a window not into darkness, but into the powerful forces that sculpt the light. While the keyhole shows us a star clearing its own cradle, other nurseries operate on a scale that dwarfs our entire neighborhood. NGC 2070, the Tarantula Nebula, is not merely a cloud of gas in our Milky Way. It is a titan residing in the Large Magellanic Cloud, a small satellite galaxy trailing our own through the cosmos. To grasp its immensity, consider this: if the Tarantula were placed at the same distance as the Orion Nebula, the closest major star factory to Earth, it would not just be a fuzzy patch in the sky. It would span an area equivalent to 60 full moons, glowing so brightly it would cast visible shadows on the ground at night. Its light would dominate the heavens. This is a stellar metropolis of breathtaking proportions, a seething cauldron of creation where stars are born in frantic, violent clusters. At its heart lies the true engine of this chaos, a region called R136. This is not a gentle nursery, but a blistering powerhouse, a dense knot of newborn stellar giants. R136 contains some of the most massive and luminous stars ever catalogued, monsters that make our sun look like a faint ember. These are stars that live fast and die young, burning through their nuclear fuel in just a few million years. Their radiation is so intense it does not just illuminate the surrounding gas, it violently erodes it. The nebula's iconic spidery filaments, those glowing strands that give the tarantula its name, are not static structures. They are the sculpted remains of vast gas clouds, carved and ionized by the hurricane-force stellar winds and ultraviolet fury blasting from these colossal newborns. The nebula is a constant battlefield where the energy of new life tears at the material that birthed it. For astronomers, the tarantula is far more than a spectacular sight. It serves as a crucial local proxy for the starburst galaxies that illuminated the early universe. In that ancient era, galaxies frequently underwent massive, frantic waves of star formation, far more intense than anything seen in the modern Milky Way. By studying the tarantula up close, we get a front-row seat to the physics governing those extreme environments. We witness how such concentrated star birth can blow gigantic bubbles in space, trigger successive generations of stars, and ultimately seed galaxies with the heavy elements forged in stellar explosions. The Tarantula Nebula is a window back in time, showing us the raw, untamed process of cosmic construction that built the universe we see today. But even the titanic star factories of the Tarantula are governed by the same universal laws that dictate a star's final, delicate farewell. Sometimes that farewell is delivered by a cosmic duo. NGC 3132, the Southern Ring or 8-burst nebula, presents a celestial scene of deceptive simplicity and profound mystery. To the eye, it is a stunning, nearly symmetrical bubble of glowing gas, its delicate filaments resembling the petals of a cosmic flower or the pattern of an 8-pointed star. At its very heart, however, shine two stars, not one. This is the puzzle. The brighter, more obvious star seems like the clear culprit, the dying sun that expelled this beautiful shell. Yet, astronomy reveals a fascinating twist. That brilliant point of light is merely a bystander, an unrelated main sequence star that happens to lie along our line of sight, a foreground object accidentally placed at the center of the drama. The true architect of the nebula is its faint, humble companion, a white dwarf. This tiny, Earth-sized ember, glowing faintly from residual heat, is the corpse of the star that actually died. It is this faint white dwarf's intense ultraviolet radiation that makes the entire nebula fluoresce, painting the expanding shell with ethereal light. The presence of this binary pair, even if one is an optical illusion, is crucial. For many planetary nebulae, a companion star is the hidden sculptor. While the 8-burst appears beautifully round, subtle asymmetries in its structure hint at the gravitational influence of that brighter companion during the death process. In a true binary system where both stars are gravitationally bound, the dance becomes far more complex. As the dying star swelled into a red giant, its outer atmosphere could have been stripped away by the gravity of its partner, funneling material into a disk or pulling it into strange, non-spherical shapes. This process, called mass transfer, can explain the incredible diversity of forms we see, from butterfly wings to complex hourglasses. The 8-burst nebula, with its central stellar masquerade, serves as a perfect gateway to understanding this dynamic. It teaches us that to decode the final message of a dying star, we must look past the obvious light and search for the faint, powerful presence that truly holds the answer. The serene beauty of the nebula is not just a monument to an ending, but a complex fossil record of a gravitational relationship, a last dance frozen in glowing gas. That delicate interplay of light and gravity in a nebula's final act is mirrored on a scale billions of times larger in the architecture of entire galaxies. Stretching across the darkness in the constellation Coma Berenices is a celestial splinter of light, NGC 4565, the Needle Galaxy. From our vantage point on Earth, we see it perfectly edge-on, a razor-thin sliver of stars and dust. This is not a blurry smudge, but a crisp, luminous line bisected by a stark, dark lane that runs its entire length. That darkness is not empty space, it is the galaxy's own thick band of cosmic dust, a lane so dense it blocks the brilliant light of the billions of stars behind it. On either side of this dark divide, the galaxy's central bulge swells slightly, a glowing hub of older yellow stars, giving the needle a subtle, elongated diamond shape. For amateur astronomers, this galaxy is a prized target. In a modest telescope under a dark sky, it reveals itself not as a faint fuzzy patch, but as a distinct, ghostly slash of light, a tangible structure floating in the void. Its clarity and perfect orientation make it feel almost close enough to touch, a cosmic ruler laid across the heavens, but its value is far more than aesthetic. The Needle Galaxy is a gift to science because of its perspective. When we look at a spiral galaxy face-on, like the famous whirlpool, we are dazzled by its grand design arms, but we lose crucial information about its third dimension. We cannot easily tell how thick the disk is, how the stars are distributed above and below the central plane, or how dust lanes are structured in depth. NGC 4565 removes that confusion. Its edge-on view acts like an X-ray, allowing astronomers to dissect its vertical structure. By studying the faint glow of stars that extends above and below the dark dust lane, they can measure the precise thickness of the galactic disk. They can see how the dust is concentrated in a thin, dense layer along the equator, much like the ring of Saturn, but on an incomprehensibly vast scale. This silhouette reveals the skeleton of a spiral galaxy. The bright central bulge tells the story of its ancient core, while the thin, extended disk, peppered with the pink glow of hidden star-forming regions peeking through the dust, speaks of its ongoing evolution. Every detail in that sharp profile, from the subtle flare at the edges of the disk to the way the dark lane obscures the very center, provides a critical data point for understanding how galaxies like our own Milky Way are built, how they maintain their shape, and how they will change over billions of years. The Needle Galaxy is a masterclass in cosmic perspective, proving that sometimes to truly see the structure of something immense, you must view it from the side. Deep within the heart of a cosmic empire lies a galaxy that rules through chaos. NGC 1275, the dominant galaxy of the immense Perseus cluster, is not a serene island of stars but a monstrous engine of violence and strange beauty. It is classified as a CD galaxy, a supergiant elliptical that has gorged itself on countless smaller galaxies over eons, growing to a truly gargantuan size. This is the gravitational sovereign of its domain, sitting at the center of a swarm of thousands of other galaxies, all bound together in a single, titanic structure. But its reign is not quiet. At its core rages one of the most powerful active galactic nuclei known, a supermassive black hole feeding on a relentless downpour of gas and dust. The energy released from this feast is beyond comprehension, and it does not stay hidden. Instead, it erupts outward in opposing jets of relativistic particles, shooting into the surrounding space at nearly the speed of light. These jets slam into the incredibly thin, superheated gas that permeates the entire cluster, known as the intracluster medium. This collision creates immense shock waves and carves out colossal cavities in the gas, visible only to X-ray telescopes. Yet the most haunting and peculiar features are the delicate filaments. Stretching for tens of thousands of light years from the galaxy's core are wispy, thread-like structures of glowing gas. They should not exist. According to all simple models, the intense heat and turbulence of the cluster environment should have torn these fragile strands apart in a matter of millions of years, a mere blink in cosmic time. But they persist, weaving through space like ghostly cobwebs. The secret to their survival is magnetism. Astronomers discovered that these filaments are permeated by powerful magnetic fields. Think of these fields as a cosmic skeleton, an invisible scaffolding that provides structure and support. The magnetic force holds the hot gas in these delicate threads against the relentless forces that seek to dissolve them. This creates a stunning cosmic paradox. The most violent object in the region is responsible for creating structures of eerie, delicate beauty. Furthermore, this violent activity serves a critical regulatory function, a process astronomers call feedback. The energy blasting from the black hole heats the surrounding intracluster medium, preventing it from cooling down, collapsing under gravity, and forming trillions of new stars. In essence, the monster at the heart of the Perseus cluster is putting a lid on its own empire's growth. It is a self-regulating system where the black hole's ferocious appetite ultimately stifles the birth of stars across the entire cluster. This galaxy is a master of its domain not through peace, but through controlled eruptions, using its own destructive power to maintain a cosmic balance and sculpt the landscape with magnetic threads of its own making. Far from the dense galactic clusters and ancient giants, star formation can unfold in a more pristine, elemental state. Our 14th strange object, NGC 602, resides not in the Milky Way but in the wing of the Small Magellanic Cloud, a small, irregular galaxy that orbits our own. This is a stellar nursery of a different kind, blazing with the light of infant stars so massive and hot they appear blue-white against the darkness. The cluster itself is dazzling, a tight-knit family of several hundred young stars, many less than 5 million years old. To put that in perspective, when the first ancestors of humanity were walking the Earth, these stars were just beginning to shine. But the true magic of NGC 602 lies in its interaction with its cradle. The cluster is embedded within a vast nebula, a cloud of gas and dust that gave it birth. The most massive stars in the cluster are cosmic bulldozers. Their intense ultraviolet radiation and powerful stellar winds are violently eroding the very cloud that created them, blowing a gigantic cavity in the nebula's heart. At the edges of this expanding bubble, the forces of creation and destruction meet. Here, the radiation sculpts the remaining gas and dust into breathtaking pillars and elephant trunks, towering ridges that point back toward the cluster's center. These structures are hauntingly familiar, direct cousins to the iconic pillars of creation in our own galaxy. They are sites where the erosion may actually trigger a new wave of star formation, as the shockwaves compress pockets of gas to the point of collapse. NGC 602 is more than just a pretty picture. It is a vital scientific laboratory. The small Magellanic Cloud has what astronomers call low metallicity. This means it contains far fewer heavy elements like iron and silicon than the Milky Way. These elements are forged in stellar furnaces and scattered by supernova. Because this galaxy is less chemically enriched, its gas resembles the raw material available in the early universe. Studying star formation here in NGC 602 shows us how the first generations of stars might have been born in an environment without the complex dust grains that help clouds cool and fragment in our own galaxy. The Hubble Space Telescope's piercing gaze has revealed an even more tantalizing detail within these sculpted pillars. Around some of the youngest, faintest stars in the cluster, astronomers have spotted small, dark disks. These are proto-planetary disks, swirling reservoirs of gas and dust from which planets could one day form. This discovery is profound. It tells us that even in this primordial, low metallicity environment, the fundamental process of planet building is already underway. The brilliant stars of NGC 602 are not just carving art into the cosmos. They are lighting up a chapter from the universe's distant past, showing us that the ingredients for new worlds exist almost everywhere stars are born. A butterfly of gas born from stellar death flutters against the black. NGC 2440 is a planetary nebula, but it defies the serene symmetry of a ghostly bubble. This is a cosmic butterfly with tattered, chaotic wings, a structure that speaks of a violent and turbulent demise. The two main lobes of gas billow outward in opposite directions, but they are not mirror images. One appears more compact and knotty, the other more extended and diffuse, as if the dying star coughed out its atmosphere in fits and starts, changing the direction and intensity of its final breaths over time. This suggests not one, but multiple episodes of mass ejection, where powerful gusts of stellar wind shot out along different axes, sculpting the intricate filaments and complex patterns we see today. The sheer disorder is a clue that something disrupted the star's attempt to die a quiet, spherical death. The leading suspect is often a binary companion, a second star whose gravitational dance could have tugged and funneled the outflow into these opposing jets. But another, more speculative idea exists. Could the gravitational influence of surviving planets, their orbits thrown into chaos as the star swelled into a red giant, have also played a role in disrupting the outflow? It is a fascinating possibility that worlds born from the star's earlier life might have helped shape its funeral shroud. Yet the true heart of this nebula's ferocity is not its shape but its engine. At the center of this beautiful chaos lies one of the hottest white dwarf stars ever measured. This stellar ember, the collapsed core of the original star, burns with a surface temperature exceeding 200,000 Kelvin. To grasp that heat, our sun's surface is a relatively mild 5,800 Kelvin. This white dwarf is over 30 times hotter, a searing pinpoint of ultraviolet fury that makes the entire butterfly glow. It is this intense radiation that ionizes the expelled gas, causing it to fluoresce in vivid colors. The chaotic wings of NGC 2440 therefore tell a two-part story. First, the messy, asymmetric shape records the dynamic and likely interactive process of the death itself. Second, the blinding light at its center reveals the staggering energy now locked within the tiny, dense remnant left behind. This celestial butterfly is not a symbol of delicate life, but of a spectacularly violent transformation, where a star's end is etched across light years as a monument to its final, fitful struggles. Its whimsical shape hides a voracious stellar nursery. Number 16 on our journey is NGC 281, better known as the Pac-Man Nebula, and the resemblance is delightfully uncanny. Through a telescope, it appears as a bright, rounded blob of glowing gas with a distinct wedge-shaped bite taken out of its side. This dark gash is not a hole, but a thick lane of cold, opaque dust that blocks the brilliant light from behind, creating the perfect silhouette of a hungry, open mouth. This cosmic Pac-Man is not a static image, but a dynamic region of frantic creation and destruction. It is an emission nebula, a vast cloud of hydrogen gas that is being lit up from within. The power source is a young, energetic open star cluster called IC 1590, embedded deep in the nebula's heart. The most massive stars in this cluster are stellar behemoths burning ferociously hot and bright. They flood their surroundings with an intense torrent of ultraviolet radiation. This radiation is so powerful it strips electrons from the hydrogen atoms in the surrounding cloud, a process called ionization. When those electrons eventually recombine with the atoms, they release energy in the form of the characteristic red glow we see, painting the nebula in vivid light. But the radiation does more than just illuminate, it also erodes. The Pac-Man's iconic shape is a direct result of this cosmic erosion. The dark dust lane represents a region where the dust is still thick enough to withstand the onslaught, casting that sharp shadow. Elsewhere, the radiation and stellar winds from the young stars are actively eating away at the nebula material, sculpting its edges and clearing cavities. Within this turbulent environment, we find the seeds of future stars. Scattered throughout the nebula, particularly along the edges of the dark dust lane, are small, dark, teardrop-shaped blotches. These are Bok globules, named after astronomer Bart Bok. They are incredibly dense, cold pockets of gas and dust, so compact that their own gravity is beginning to pull them inward. They are cosmic wombs, shielding the earliest stages of star formation from the violent radiation outside. Over hundreds of thousands of years, these globules will collapse further, potentially igniting nuclear fusion in their cores and becoming new stars, some of which may one day clear their own spaces in the nebula. The Pac-Man Nebula is a snapshot of the stellar life cycle in action. We see the brilliant young stars of IC 1590. We witness their power shaping and energizing their birthplace, and we see the next generation already condensing in the shadows. It is a place where the universe plays with familiar shapes while conducting the serious business of building suns. The delicate chaos of a dying star can give rise to a creature of pure cosmic fury. NGC 6302 is known as the Bug Nebula, or more poetically, the Butterfly Nebula, and it is one of the most extreme and complex farewells ever witnessed. This is not a gentle bubble, but a raging, bipolar structure stretching over 3 light years across. At its center is a pronounced dark waste, a thick belt of dust and molecules that cinches the nebula like an hourglass. From this constriction erupt 2 gigantic wings of gas, each heated to temperatures exceeding 20,000 Kelvin, glowing fiercely in ultraviolet light. These are not static wings but turbulent flows, expanding at speeds of over 600,000 miles per hour, laced with intricate filaments and knots that resemble the detailed veins of an insect's wing. For decades, the engine of this spectacular explosion remained hidden. The central star, the white dwarf that powered this entire display, was completely shrouded by that dense equatorial disk of dust invisible to all telescopes. It was a ghost in the heart of its own monument. Only recently, with the piercing vision of the Hubble Space Telescope, was this stellar corpse finally detected directly, a searing pinpoint of light with a surface temperature estimated at a staggering 250,000 Kelvin, one of the hottest white dwarf stars known. This discovery solved one mystery but deepened another. The chemical composition of the bug nebula is bizarre. Its dust is extraordinarily rich in hydrocarbons, the molecular building blocks of soot. How did a dying star, which should have been fusing hydrogen and helium into heavier elements like carbon and oxygen, create such a complex organic brew? Astronomers believe the answer lies in the star's violent final act. As it shed its outer layers, the conditions in the expanding shell may have been just right for carbon atoms to link together into chains, forming these molecules in the cold, dark recesses of the outflow. It is a process akin to a candle flame producing smoke, but on a stellar scale. The bug nebula, therefore, is more than a beautiful insect of light. It is a chemical factory, demonstrating that the violent death throes of a star can forge the complex ingredients for future cosmic chemistry. Its spectacular form is a fossil record of a star that did not just expire, but tore itself apart in a directed, ferocious outburst, leaving behind a blistering ember and a pair of incandescent wings painted across the void. The cosmic butterfly's furious wings give way to a vast, watchful eye. NGC 7293, the Helix Nebula, stares back at us from the constellation Aquarius. This is not a distant speck, but one of the closest planetary nebulae to Earth, a mere 700 light-years away. That proximity transforms it from a faint smudge into a sprawling, intricate structure that nearly fills the sky with the apparent size of a full moon. Its popular nickname, the Eye of God, is chillingly apt. Through powerful telescopes, it appears as a colossal ring of glowing greenish-blue gas, a cosmic iris with a dark, hollow center. At the very heart of that darkness burns the central white dwarf, a stellar ember so hot it radiates a ferocious blast of ultraviolet light. This radiation is the paintbrush that illuminates the entire scene, causing the vast shell of expelled gas to fluoresce. But the Helix's true strangeness lies in the fine details of its iris. Sprinkled throughout the glowing ring are thousands upon thousands of mysterious knots. Each one resembles a tiny comet with a bright, condensed head and a long, faint tail streaming radially away from the central star. Do not be fooled by their appearance, these are not comets. Each of these knots is a behemoth, a gaseous structure larger than our entire solar system. They are the final, desperate remnants of the star's original atmosphere. As the dying star shed its outer layers, the expanding gas did not flow out smoothly. Instead, it fragmented, much like a smoke ring breaking apart into discrete puffs. These puffs, denser and richer in molecules than the surrounding thin gas, are the knots. Now they are under siege. The intense ultraviolet light from the central white dwarf is slowly boiling them away, ionizing the gas at their surfaces and blowing it off into space. The spectacular tails we see are not trails of motion, but the glowing streams of this evaporated material, pointing directly away from the source of the destructive radiation. It is a slow-motion disintegration on a cosmic scale. The Helix Nebula offers us a ringside seat to the final dissolution of a star's legacy. Because it is so close, astronomers can study these evaporating gaseous globules in exquisite detail, watching as they are eroded over centuries. This process teaches us about the ultimate fate of planetary nebulae. They are not permanent monuments. Over tens of thousands of years, the fierce radiation from the central white dwarf will completely dissipate the glowing shell. The knots will vanish, the gas will expand and fade into the interstellar medium, and all that will remain is the cooling white dwarf, a silent diamond in the dark. The helix is a snapshot of a beautiful, transient phase, a star's final, glowing breath caught in the act of vanishing before our eyes. A star's violent wind carves its own tombstone in the gas. NGC 6888, the Crescent Nebula, is not the gentle arc its name might suggest. This is a blistering shockwave etched across space, a glowing testament to a star living on the edge of catastrophe. The architect is a rare and ferocious type of star known as a wolf-rayet star. Imagine a star that began its life with at least 20 times the mass of our Sun. It has burned through its nuclear fuel at a frantic, profligate rate, and now, in its final evolutionary stage, it is literally tearing itself apart. The star's core is exposed, blazing with unimaginable heat, and it is ejecting its own outer layers into space at speeds exceeding 4 million miles per hour. This is not a gentle solar breeze, but a hurricane of stellar material. The crescent shape we see is the glowing edge of a colossal collision. This supersonic wind is slamming into slower-moving shells of gas that the same star expelled tens of thousands of years earlier when it was a red supergiant. Where these two epochs of the star's life meet, a powerful shock front is formed. The gas at this boundary is compressed and heated to extreme temperatures, causing it to glow with intense energy. We are seeing a cosmic sonic boom frozen in luminous gas. Wolf-rayet stars are among the most luminous and hottest stars known, but their glory is tragically brief. This phase lasts only a few 100,000 years, a mere heartbeat in stellar terms. They are stars in a desperate rush, shedding their hydrogen envelopes to reveal their helium-burning cores, racing toward their inevitable and spectacular demise. Nebulae like the Crescent are therefore more than just beautiful structures, they are urgent warning signs. They mark a star in its final act. The complex filamentary structures within the nebula are a direct record of the instability and violence churning within the star itself. This entire system is a prelude to one of the universe's most energetic events. When this wolf-rayet star finally exhausts its nuclear fuel, its core will collapse, triggering a supernova explosion of staggering power. The Crescent Nebula is the last magnificent breath before the final scream, a glowing ripple in the pond of space that tells us a cataclysm is imminent. Even the most violent stellar winds can create objects of serene, geometric perfection. Our 20th strange object is NGC 7635, the Bubble Nebula, a celestial soap bubble floating against the tapestry of the Milky Way. Its appearance is startlingly artificial, a nearly perfect sphere of glowing gas that seems too round, too delicate to be a natural phenomenon. At its heart lies the artist, a massive, ferociously hot star known as SAO 20575. This is an O-type star, a true stellar titan that burns tens of times hotter and hundreds of thousands of times brighter than our Sun. Such stars live fast and die young, and they spend their short lives blasting their surroundings with a hurricane-force wind of charged particles. This relentless stellar wind is the sculptor's tool. It streams outward from the star at millions of miles per hour, pushing against the surrounding interstellar medium. But the Bubble Nebula is not expanding into empty space. It is plowing directly into a much denser, colder molecular cloud, a vast region of gas and dust. This is the key to its perfect shape. Imagine blowing a bubble with a wand inside a room filled with thick, still fog. The bubble forms a crisp, round boundary where the force of your breath meets the resistance of the dense air. That is precisely what is happening here on a cosmic scale. The star's powerful wind excavates a cavity within the molecular cloud, and the pressure from the cloud itself presses back uniformly, molding the outflow into that spectacular sphere. The bubble's surface, that sharp, glowing edge, is a shock front. It is the very place where the supersonic stellar wind collides with the almost stationary cloud material. The gas at this boundary is compressed and heated violently, causing it to glow with intense energy. Meanwhile, the star's fierce ultraviolet radiation floods the interior of the bubble, ionizing the gas and making the entire shell fluoresce in beautiful hues of blue and orange. The bubble nebula is a snapshot of dynamic balance, a temporary equilibrium between creation and resistance. The star's wind constantly tries to expand the bubble, while the dense cloud outside constantly works to crush it. For now, they are locked in a standoff, resulting in this breathtakingly precise object, but this balance is fleeting. The massive central star is destined for a supernova explosion in the astronomically near future. When that happens, the bubble will be obliterated in an instant, its perfect form swallowed by a far greater cataclysm. For now, it hangs in space, a fragile-looking but powerful testament to the sculpting force of a star's breath. That delicate cosmic bubble is a fleeting moment of balance, but some encounters in the universe are anything but balanced. Two spiral galaxies, NGC 4038 and NGC 4039, are locked in a slow-motion dance of mutual destruction. We know them as the Antennae galaxies, and the name comes from the most spectacular result of their collision. Two incredibly long, faint streams of stars, gas, and dust have been violently pulled out from the hearts of each galaxy, stretching across hundreds of thousands of light-years into the darkness. These are tidal tails, and they curve away from the galactic cores like the graceful, sweeping antennae of some colossal insect. This is not a static sculpture, but a snapshot of an ongoing catastrophe. Roughly 1.2 billion years ago, these two galaxies, each once resembling our own serene Milky Way, passed too close to one another. Their immense gravitational fields did not simply nudge each other, they tore each other apart. Like two swirling pools of water crashing together, their structures were utterly disrupted. The graceful spiral arms were shredded, and stars were flung out on vast, looping trajectories, creating those luminous tidal streams. But the true chaos is in the center, where the galactic cores are now in their second close pass, finally merging into a single, chaotic entity. The collision has triggered a firestorm of creation. All that gas and dust, violently compressed by the gravitational forces of the merger, has ignited a frenzied burst of star formation, a starburst of epic proportions. The galaxies blaze with the light of millions of newborn stars, concentrated into brilliant blue superstar clusters. These clusters are the nurseries for stellar giants, stars so massive they live fast and die young. Scattered among them are the glowing remnants of those short-lived stars that have already exploded as supernova, adding their enriched debris back into the turbulent mix. This nearby cosmic wreck gives us a front-row seat to a process that shaped the universe. In the early cosmos, galaxies were smaller and collisions were frequent. Through mergers like this one, small galaxies built up into the large ellipticals and spirals we see today. The antennae are a living fossil of that era, showing us the mechanism of galactic growth in brutal, beautiful detail. And this scene is not just a relic of the past, it is a preview of our own future. In about 4 billion years, our Milky Way and the neighboring Andromeda galaxy are destined for a similar collision. While it is unlikely our solar system will be destroyed, the night sky from Earth, should any eyes remain to see it, will transform into a breathtaking and terrifying panorama. The familiar band of the Milky Way will be gone, replaced by a chaotic swirl of merging stars and glowing gas, a new combined galaxy taking shape in a blaze of stellar birth. The Antennae galaxies show us that even on the grandest scales, the universe is a dynamic and often violent place, where destruction and creation are two sides of the same cosmic coin. This grand cosmic bubble wears the name of a god. NGC 2359 is Thor's helmet, an emission nebula of truly heroic scale and violence. Its shape is unmistakable, a vast central bubble of glowing gas flanked by two sweeping, filamentary extensions that curve outward like the winged helmet of the Norse thunder god. The artist responsible for this celestial armor is another Wolf-Rayet star, a ferocious beast known as HD 56925. This star is in its final, desperate act, having already shed its outer hydrogen envelope to reveal its searing hot helium core. It now blasts its surroundings with a stellar wind of unimaginable speed and power, a supersonic hurricane of particles. This wind is the chisel. It plows relentlessly into the surrounding clouds of interstellar gas and dust, carving out a gigantic cavity and piling up the displaced material into that bright, sharp-edged shell we see as the helmet's dome. The extended wings are likely ancient structures, sculpted by earlier, slower episodes of mass loss from the star when it was in a different phase of its life, now illuminated and reshaped by the current onslaught. But Thor's helmet holds an even more explosive secret. Radio observations of the region have revealed something startling: faint, filamentary structures that bear the signature of a supernova remnant. This suggests the violence here is not just ongoing, but has a deeper history. One compelling theory is that the central Wolf-Rayet star may have once had a massive companion, a binary partner that has already exploded. The shockwave from that ancient supernova could have swept up surrounding material, creating the perfect dense shell for the surviving star's wind to now collide with, enhancing the nebula's brilliant glow. Alternatively, the star itself might have undergone a kind of supernova imposter event in the past, a titanic eruption that ejected a shell of material without completely destroying the star, and it is now blowing a bubble inside that pre-existing wreckage. Either scenario paints a picture of a region that has endured multiple cataclysms. Thor's helmet is not a static monument, but a glowing testament to successive waves of stellar violence, a story written in expanding shockwaves and luminous gas. It reminds us that the most dramatic structures in space are often born from a history of repeated trauma, where each explosion sets the stage for the next act of cosmic creation. This vast continent of light sprawls across the constellation Cygnus, an unmistakable silhouette against the starry sky. NGC 7000, the North American Nebula, is an emission nebula so large and so familiar in shape that it feels almost like a cosmic landmark. Its outline is uncannily precise: a glowing Gulf of Mexico, a dark Atlantic seaboard, and a bright, sprawling landmass reaching up toward the Cygnus wall, a region of dense gas and dust that forms the nebula's central spine. But this is not a continent sculpted by geology, it is a portrait painted by shadow. The shape we recognize is not made by the glowing gas itself, but by the chance alignment of inkai, opaque dust clouds that drift in the foreground, blocking the brilliant red light of the hydrogen behind them. It is a celestial silhouette, a continent-sized stencil where darkness defines the form. This nebula is not alone. It shares its cosmic neighborhood with another avian-shaped cloud, the Pelican Nebula, IC 5070. They are not separate entities, but two bright regions of the same, far vaster interstellar cloud, divided by that same lane of obscuring dust. Together, they form a single, titanic star-forming complex, a stellar nursery hundreds of light-years across. Within its glowing folds, particularly in the Cygnus wall, new stars are condensing from the gas, their fierce radiation eroding the surrounding material into pillars and ridges. Yet for all its prominence and iconic shape, the North American Nebula has guarded its secrets stubbornly. Two fundamental questions have long puzzled astronomers. First, how far away is it? For decades, distance estimates varied wildly from 1,000 to 2,000 light-years, a frustrating uncertainty for an object so large and bright. The confusion arises because the nebula is not a simple, compact object, but a sprawling, complex structure that likely lies at different depths along our line of sight. Only recent, precise measurements have begun to pin it down to around 2,200 light-years. The second, deeper mystery is what exactly is lighting it up. An emission nebula glows because ultraviolet radiation from hot, young stars ionizes the hydrogen gas. For a nebula this immense and bright, you would expect to find a corresponding cluster of massive, brilliant stars at its heart, a clear power source. But for the longest time, no such obvious cluster could be identified. The leading suspect is a brilliant but distant star named Deneb, the tail of the swan, one of the brightest stars in our sky. Deneb is a supergiant capable of flooding vast regions of space with ionizing radiation. Yet its exact role remains debated as the geometry and distance are complex. It is possible that Deneb, along with other, fainter stars embedded within the nebula itself, provides a collective light that brings this continent of gas to life. The North America Nebula stands as a beautiful reminder that even the most recognizable features in the cosmos can be the most deceptive, their familiar faces masking profound and persistent questions about their true nature and origin. A continent of gas gives way to a stellar battlefield of almost unimaginable fury. NGC 3372, the Eta Carinae Nebula, is a sprawling, chaotic realm of creation and destruction so vast it outshines even the great Orion Nebula. This is not a serene cloud but a violent stellar nursery, a cauldron where the raw forces of the universe are on full display. Towering pillars of dark dust, reminiscent of the pillars of creation but on a more colossal scale, stand against a backdrop of glowing pink hydrogen gas. Brilliant young star clusters blaze like diamonds scattered on velvet, their intense radiation sculpting the surrounding material into fantastical shapes, including dark, tadpole-like globules known as Bok globules, each a potential future star. Yet all of this cosmic drama orbits a single, terrifying presence at the nebula's heart, the star Eta Carinae itself. This is not a normal star. It is a luminous blue variable hypergiant, one of the most massive and unstable stars known in our galaxy. Its mass is estimated to be well over 100 times that of our Sun, and it radiates with the fury of 5 million suns. Eta Carinae is a star living on borrowed time, perpetually on the verge of tearing itself apart. The most spectacular evidence of its instability surrounds it, a smaller nebula within the larger one, known as the homunculus. This bizarre bipolar structure resembles a celestial hourglass or a pair of vast glowing lungs. It is not ancient. This cloud was created in a single, catastrophic event witnessed by astronomers in the 1840s called the Great Eruption. For over a decade, Eta Carinae became the second brightest star in the night sky, despite being 7,500 light-years away. It ejected an amount of material equivalent to at least 10 times the mass of our Sun, but in a strange, non-explosive event. The star did not go supernova, it simply burped out a significant portion of its own atmosphere, forming the homunculus. This expanding cloud, now lit from within by the hidden star, is a three-dimensional fossil of that eruption, allowing us to study its geometry and composition in exquisite detail. Today, Eta Carinae remains shrouded within this dusty cocoon, its true surface hidden from view. It is a ticking time bomb. Stars this massive are not meant to last. Their immense cores burn through nuclear fuel at a prodigious rate, and they are prone to violent instabilities. Astronomers watch it closely, knowing its end is inevitable and relatively imminent in cosmic terms. It could explode as a supernova within the next several thousand years, or even in our own lifetimes. Given its extreme mass, it might not even produce a typical supernova, but a hypernova. An explosion of such staggering energy, it will be accompanied by a long-duration gamma-ray burst, the most powerful type of explosion in the universe since the Big Bang. While we are safely distant, such an event would temporarily outshine the full moon in our sky, visible even in daylight. The entire Eta Carinae Nebula, with its beautiful pillars and glowing gas, is therefore a monument to this star's past violence and a preview of its cataclysmic future. It is a grand stage where the life cycle of the most extreme stars plays out, reminding us that the cosmos is not always a place of quiet equilibrium, but often a theater of spectacular, unstable brilliance. The final act of a star can be a solo performance or a duet that twists the cosmos into a spiral. Our 25th and final strange object, NGC 5189, is a planetary nebula that defies every expectation of a simple spherical farewell. From a distance, it resembles a glowing celestial ribbon or a bizarre cosmic question mark etched in luminous gas. This is not the serene bubble of the Helix or the chaotic wings of the Bug Nebula. It is something entirely different, an intricate S-shaped structure that looks more like a barred spiral galaxy in miniature than the grave of a single star. The key to this impossible shape lies in the heart of the nebula, where astronomers believe not one but two stars are locked in a gravitational dance. This is a binary system, and their orbital motion is the sculptor. As the primary star died, expelling its atmosphere into space, the outflowing gas did not expand evenly in all directions. Instead, it was caught in the gravitational whirlpool created by the two stars orbiting each other. Think of a spinning garden sprinkler where the water streams out in a spiral pattern as the head rotates. On a cosmic scale, that is what we are witnessing. The central binary system acts as the spinning sprinkler head, and the expelled stellar material is the water, twisted into a vast glowing spiral over thousands of years. The intricate details revealed by telescopes like Hubble are breathtaking. The nebula is not a single smooth shell, but a tapestry of multiple lobes and outflows, all oriented at different angles. Bright knots of denser gas are strung along the central bar like beads on a string, while faint, delicate filaments trace the edges of the spiral arms. This morphological complexity is a direct fossil record of the system's dynamic history. Each lobe may represent a separate episode of mass loss, with the binaries changing orientation, subtly steering the direction of each new outflow. NGC 5189 stands as one of the most important objects for understanding the final chapters of stellar evolution. It provides some of the clearest visual evidence that a binary companion can dominate the death of a star, transforming a potentially spherical event into a work of elaborate three-dimensional art. This celestial spiral is a final, twisted signature, proving that even in death, a star is not always alone, and that the gravity of a companion can write a far more beautiful and complex ending across the light years. From the delicate spiral of a binary star's final breath to the explosive fury of galactic mergers, we have journeyed past 25 cosmic anomalies that defy simple explanation. Each entry in the new General Catalogue, from the flickering ghost of Jupiter to the continent-sized silhouette of the North American Nebula, is more than a number. It is a doorway into a specific, profound mystery of our universe. We have witnessed stars that die in chaotic butterflies and serene bubbles, galaxies that cannibalize their neighbors, and dark voids that are not objects but the scars of stellar birth. This incredible diversity reveals a cosmos that is not static or orderly, but a dynamic arena of constant transformation, where beauty is born from violence and structure emerges from chaos. The NGC is far more than a dusty astronomical list. It is a living map to the universe's greatest wonders and its deepest, lingering puzzles. Every strange shape and unexpected glow is a question waiting for an answer, a cosmic story half told. So tell me, which of these celestial marvels captured your imagination the most? Was it the haunting eye of the Helix, the violent dance of the Antennae, or the perfect bubble blown by a stellar giant? Let me know in the comments below, and if you enjoyed this tour of cosmic oddities, be sure to like this video and subscribe for more journeys into the mysteries of space. The next time you look up at the night sky, remember, these are not just points of light. They are galaxies colliding, stars being born, and nebulae glowing with the ghosts of suns. The greatest show in the universe is always playing, and you have a front row seat.